Hi, Room 19, Mr. Vendetta back again with another video. Tonight we are going to be scientists. Scientists are people who are trying to discover something. And there are many different types of scientists depending on what you're trying to discover. So, for example, scientists who are trying to discover things about the Earth are called geologists. Scientists who are trying to discover things about outer space are called astronomers. Scientists who mix things together, like powders and liquids, to see what happens when they mix them together are called chemists. And scientists who study how things move are called physicists. That's a fun word to say, physicists. A lot of S's in there. Anyway, we know that architects are scientists who build houses and buildings, and engineers are scientists who build just about everything else, from spaceships to computers to cars to toys to the rides at Disneyland. We can thank engineers for that. So anyway, we are going to be scientists, and I'm going to show you the results of two experiments that I did. These are experiments that you can do at home with your parent or an adult who is at your home. And they use things, the materials or the supplies that we need for these two experiments are things that you probably already have around your house. And if you don't, they're easy to find down at the dollar store or Safeway or CVS or even Target. So two experiments tonight. The first one is definitely a chemistry experiment. So we're going to be chemists on that one. We're going to be seeing what happens when two things mix together. The other one, I'm not quite sure what kind of science this is. It might be geology, which is scientists who study the Earth. That's geology, the study of the Earth. It might be chemistry. I'm not sure exactly. But they are two fun experiments, and you will learn something new, and you will see something new as well. So here's the first one, and this is the chemistry experiment. Now for this experiment, I needed something. It's a liquid. Liquids can be poured, and they always take the shape of the container that they're in. So if you tip it this way, it's shaped like that. If you tip it that way, it's shaped like that. Anyway, this liquid, it looks like water, but it's not water. It's called white vinegar. And that is what I'm going to need tonight, is white vinegar for this first experiment. Now, I did this experiment yesterday just to make sure that it would work, and I wanted to be able to show you the result. Now, I said that word result earlier. A result is what happens at the end of your experiment. That's what the scientists are looking for. What was the result? And so you do the experiment, and the result is what happens. And I wanted to show you the results of these two experiments, so I did them both yesterday. Now, here's what I did. I took a plain old egg. Plain old egg. This is a chicken egg. It came from one of my chickens in my backyard. You can see it's kind of green. She lays green eggs. My other chicken lays brown eggs. But she's been laying a lot of green eggs lately, so I borrowed one from her. So I took a plain egg. It's not cooked. It's not cooked. And I put it in a cup. And then I filled that cup with white vinegar all the way so that the egg was completely under the white vinegar. And then I left it for about 24 hours, which is a full day and night. Here's what my egg looked like after I took it out of the white vinegar. It's not green anymore. It's not white. It's not brown. It's a completely different color. It's kind of shiny looking. It's the same exact shape, but it doesn't look the same. And you know what? It doesn't feel the same either, because watch what I can do with this egg. I can squeeze it. It's soft. It's a soft egg. And you know what else I can do with this egg? Watch this. bounce it. I created a bouncing, squishy egg just by putting the egg in white vinegar overnight. Now, why did that happen? Well, white vinegar is a special type of a liquid. It's called an acid. And acids eat things or burn things. Now, white vinegar doesn't burn things. And it's certainly not going to eat anything in you, because we can use white vinegar in cooking. We can make salad dressings out of it. Some people like to put it in stews. There's red vinegar and there's white vinegar. And we can cook with both of them. They're perfectly safe to eat. But it is still an acid. And so when it comes in contact or when it touches certain things, like metal or plastic or an eggshell, it will start to eat away at that material, whether it's a metal, a plastic, or an eggshell. So as that egg was soaking in the white vinegar overnight, the white vinegar was eating the shell. But wait a minute. If the shell is gone, if the white vinegar ate the shell, then what's this on the outside of the egg? It's something called the membrane, which is like the skin of the egg. So the egg has that hard shell on the outside of it to protect it, but it's also got a soft membrane or skin right under the shell to give it a second layer of protection. In fact, the membrane is so strong that the white vinegar couldn't eat it. It ate the hard shell, but it could not eat the soft membrane. I wonder if you can hear this. It sounds a little bit like a drum. Now, inside this egg without a shell, which is squishy and bouncy, is still a perfectly good egg. In fact, when I'm done, I'm going to put this one back in the refrigerator, and tomorrow all I'll need to do is, I can't crack it, I have to just poke it with a knife and squeeze the egg out, and I've got an egg for breakfast. This is a chemistry experiment. What happened when we mixed white vinegar with an egg? We ended up with a squishy brown egg. I'm sorry, a squishy bouncy egg, because the white vinegar was able to eat the eggshell, but it was not able to eat the membrane. So we ended up with an egg that is squishy and bouncy. Now you can squeeze it pretty hard, but I wouldn't squeeze it with all your strength, because you just don't know exactly how strong that membrane is. And if you pop the egg, you're going to have a gigantic mess. And Mom and Dad are not going to be really happy. So remember, don't throw away your squishy egg after you get it squishy and bouncy, because it is still perfectly good on the inside. The membrane has protected it completely. All right. So that is called the bouncing egg. And parents, the little write-up on this activity, including the explanation of why this happened, is on the class website, our class website, under video support, video 10 folder. Okay? So, on to experiment number 2. This is the one that I'm really not sure what kind of science it is. It might be chemistry still. In fact, you know what? I think it might be, because I mixed two things together and something happened. And I'm going to show you what happened. Now, did you ever think that you would be able to bounce an egg without breaking it? Well, now we know we can. But do you think you could explode a bar of soap? Believe it or not, you can. And here it is. Yesterday, this was a perfectly normal bar of soap. A bar of Ivory soap. You can still see the name Ivory on there. But look at the sides. This soap exploded. Now, the soap is still soap. It's still perfectly good. So even though it looks a little funny, I'm not going to throw it away. I can still use it. There's some jagged edges here. I might get rid of those, but this is still a perfectly good bar of soap. So just like we didn't ruin the egg, we can still eat the egg that turned bouncy and squishy. We can still bathe with this soap. Now, how did I make this happen? Well, the first thing that you have to do is get ivory soap. It's very important that you have ivory soap because ivory soap has a lot of air in it. That's why it's very light. Some bars of soap are heavy. This bar of soap is very light. It's why it floats in water, and it's why it gets really bubbly when you wash yourself with it. So important to have ivory soap because it's got a lot of air in it, okay, in the soap. Now, I took my ivory soap, I took the wrapper off, put it on a plate, and I put it in the microwave oven and turned it on for 90 seconds. Parents, very important, 90 seconds. It's kind of like cooking microwave popcorn. You put it on for 5 minutes, but then you watch and you stop it early if you need to. Well, it's the same with this. Put it on for 90 seconds, but if you see any smoke coming out of the soap, it's not on fire. It's just starting to burn, just like meat would burn if you overcooked it. And you want to stop the microwave oven then, because if it burns, the spot where it burned, it turns it kind of a yucky color, and it's very stinky. Right now, like this, it still just smells like plain old soap. So anyway, microwave oven for 90 seconds. Stand and watch what happens. Watch this. The soap bar will do very strange things inside the microwave. Now, mom and dad, parents, when you take the soap out of the microwave, please be careful because the plate might get hot. The soap will definitely be hot, and it takes a little while for it to cool off. So you're going to want to just observe for a while, and don't touch it until it's cooled off completely. Okay, so why did this happen? And what does it have to do with all the air that's in the ivory soap? Well, here's the deal. Remember how I told you that the white vinegar that I was using is a liquid? Liquids can be poured. Well, air, the air that we breathe, is not a liquid, it's a gas. And gases float. Liquids can be poured, gases float. Air happens to be the gas that we breathe. Now, here's the interesting thing about gases. If you heat them up, they do this. They expand. What do you think expand means? Expand. They get bigger. They move outward like this. It's not exploding. It's just expanding. As the air that's inside the bar of soap gets hot, it starts to expand. And it's got nowhere to go because it's surrounded by soap. But here's what's also happening, and it's why it turns this funny shape. There are thousands of little tiny pockets of air in that bar of ivory soap. And when they all start to expand at the same time, they're bumping into each other, they're moving each other around, and that causes the soap to take on that strange shape. But watching it in the microwave is very interesting. I'm not going to tell you exactly what happens, but it is very neat to watch. So we heat up the soap, and that means we're heating up the air that's inside the soap. That air expands, and it makes it look like the soap has exploded. And like I said, I think that's a chemistry experiment because what did I do? I mixed soap, which has air in it, with what? Heat. I made it hot, and this is what happened to it. So 2 chemistry experiments tonight. That's good because we haven't done really any chemistry in class. We've done a lot of engineering in class, but not talking about chemistry too much. So both of the write-ups on these experiments, as I said before, are on the class website under video support. They're on our class website under video support, video 10 folder. You need white vinegar, you need an egg, you need ivory soap, and you need a microwave oven and a plate. And that's really about it. So I hope you do these experiments. I hope you enjoy doing these experiments. I hope you enjoy playing with the squishy, bouncy egg for a little while. Please remember, it is completely protected in here. The membrane has got it covered, just like our skin covers us. Students, children, remember that you do these experiments with one of your parents. No matter which one it is, do it with your parents, not by yourself. Anyway, that is our science video for tonight. I want you to do these experiments, and I want you to think about what kind of learning is going on from doing these experiments. What have you learned? What do you learn about acids like white vinegar when they touch certain other objects like an eggshell? What did you learn about air and heat from the soap experiment? Think about that. And there's nothing that you have to write up for this. There's nothing that you have to give to me for this. I just want you to do these experiments, and I want you to communicate with your family, because that's what scientists do the most. They communicate with other scientists. They share ideas, and that makes whatever they're trying to discover just go even faster when they work together. So I want you to have that experience of being a scientist with your family, discovering something new. Even though you've seen me with the squishy egg and the exploded bar of soap, I want you to actually create those yourself. So have a wonderful time. Parents, remember, if you need anything, I am here to help you. So just let me know what I can do. Bye-bye.